Now that we have gotten our hands dirty with a few hands-on exercises, it's time to step back and then examine a few Docker concepts. Now, before you proceed, make sure to sanitize those hands. Now, the first concept that we'll examine is what is a container. Now, I have been mentioning container over and over again in the videos without telling you what a container really is. Now is the time to ask ourselves that question. A container is a standardized unit of software. That doesn't make any sense to you, obviously. Let's examine it a bit further. So, I will use Docker's own documentation to explain what a container is. So in a typical environment where Docker runs, you have your infrastructure, which is either your computer or a cloud farm where we have computers that are running the host operating system. On top of the host operating system, you have the Docker environment running. And within the Docker environment, you have applications running in their own sandboxes, each application running in its own sandbox. And that sandbox essentially is a containerized application. Now, what exactly is a container? So to examine that further, it is a standard unit of software that packages up code and all its dependencies so that the application can run quickly and reliably from one computing environment to another. Now, that is a mouthful of words. Now, let's split it up
It's
into
12
its
o'clock.
units and then examine what exactly it means. Now, the first part, it says that it's a standard unit of software which acts as a unit that can execute on its own. The second part of that sentence says it packages up the code and all its dependencies so that the application can run quickly and reliably from one computing environment to another. So what this means is that everything that is required for your application is packaged around the application inside this container so that wherever this container executes, your application is guaranteed the execution environment and all its dependencies are available when it is running. So that makes it very easy to port your application and run it wherever and whenever you choose to. So that is the whole point about a Docker container. Now, you obviously might be wondering, how is it different from a virtual machine? We have already seen virtual machines being used on computers, perhaps from our previous experience. And one of the most common software that is used to run virtual machines is VMware. And I'm sure you have heard about hypervisors that run on various computer systems or within various operating systems that allow you to run virtual machines on them. Now, so the question is very obvious. How is a container different from a virtual machine? So let's ask and answer that question next. Now, to contrast between virtual machines and containers, here is an explanation of what a container is and how is it different from a virtual machine. A container basically virtualizes the operating system itself. What does that mean? To help us better understand, let's take a look at a diagram from the Docker documentation. This diagram clearly delineates the difference between a virtual machine and a containerized application. So in this case, if you are looking at virtual machines, the virtual machine typically runs on an infrastructure which is running a hypervisor on top, which exposes a virtualized computer for the virtual machine to execute. So the virtual machine will have a guest operating system that is unique to that virtual machine. So in principle, on an infrastructure, you could have multiple virtual machines, each running its own separate operating system. Now, this is, of course, more heavyweight compared to the way the container works. In a containerized system, which Docker uses, you have the host operating system on top of which your Docker layer is running, and that in turn supports containerized applications. Now, these containerized applications take direct help from the host operating system. So they are all dependent upon the specific host operating system on which they are running. Typically, most containers are designed around Linux. Now, of course, we have Windows-based containers. So far, there is no Mac OS-based containers available. So if you have a Windows machine, you can run Windows-based containers. If you install the Docker desktop on your Windows machine, which has its own specific requirements. But typically, when Docker was designed, it was designed around the Linux environment as its underlying base. So all containers share the common Linux environment, and on top of it, the containers themselves specialize and package the software that is required for your application to run within that container. Now, again, this may not completely clarify in your mind. You can read more details in the Docker documentation, a link to which I have provided in the description of this video. In principle, containers and virtual machines can work together. Indeed, on your computer, when you install the Docker Toolbox, what essentially you are doing is you are running VirtualBox, which is a virtual machine, and inside the VirtualBox, you are running a Linux operating system, and on top of that Linux operating system, you're running the Docker application or the Docker daemon, and on top of the Docker daemon, you're actually running the Docker containers on your machine. So in principle, there is no need for the two to be completely independent of each other. You can have virtual machines which can actually run containers inside them. And indeed, in many cloud infrastructures, that is essentially what is done in practice. With this quick understanding of what a container is, let's proceed on to the next video, where we will examine a little more details about the Docker architecture itself. Now, if you want to read more details about the Docker container, the link will be in the description of this video.